Good evening class. In this segment I am going to explain you and how to subtract a vector by the help of graphical method. So there is no particular any basic law regarding the subtraction of the vectors. As we normally add the vector by the help of this graph method, same method we will use for the subtraction but with the trick. So just see here. Let's suppose our vector A representing in this particular direction and this is our vector B. So for adding two vectors, we better know that at the point where two vector meets, so there should be head to tail addition. So let's suppose if I am joining these two vectors, okay. So at this particular point, this is called point of contact. Point of contact. So at this particular point in normal addition, one vector head and another vector tail should be added in the normal addition. But for the resultant case, as we know, for the resultant case, head will be added towards the head and tail will be added towards the tail. Let's suppose the resultant of this vector A and vector B is what? R. It is represented by vector R. So the head of this R will be towards this head and tail of this vector will be towards this, the tail of another vector. So head should be added to head and tail should be added to tail for the resultant vector. This is our basic law for the addition. Now let's suppose same vectors are there here for this particular case. This is our A vector and this was our B vector. But we have to perform subtraction. Let's suppose I need to form A minus B. So just see here how we can write A minus B. From the graphical method only addition is possible. So how we can just write addition in the form of this particular subtraction A minus B? I can write it A plus of minus B. Like this I can write it. Okay, means we have to add vector A and what? Minus B vector. So just see here that what is the significance of this minus B vector. Let's suppose if the direction of vector B is this, so the direction of minus B will be in just opposite direction of this particular vector B, like this. This is the direction of minus B. Any vector which are representing in the direction, particular direction, if we just change the direction, so that vector magnitude will remain same, but due to direction this minus term will be come. So if the vector B is represented by like this, so vector minus B will be represented like this in opposite direction. So just see here. Let's suppose now we have to add this vector A and this minus B. So rule will be remain same. Means we have to add this vector A and another vector is what? Now minus B is a vector. So we have to add these two. So in a normal law, from the normal law we better know that at the point of the contact, one head and another tail should be added. So just see here, let's suppose I am just taking this particular vector here and I am joining it. Like this I can join. This is our vector minus B. So just see here, this is our point of contact where the vectors meets. Arrow is towards the right side of vector A. So this is the head of vector A, but its arrow is in a downward direction, means it is head and it is tail. So at the point of contact, one head and one tail should be there. Now if we need to find the resultant of this two vector, vector A and another vector minus B, so just closing side of this particular two side will be the resultant. So let's suppose I am joining these two. Okay, I have joined. So the resultant the direction of the resultant will be added head to head and tail to tail. Let's suppose for this particular minus v vector, this is our head point and this is tail point, and for this particular vector A, this is head point and this is tail point. So the resultant R will be added tail to tail and head to head, means head will be towards this head and tail will be at this point. So this is our normal law related to subtraction. One more example I want to give you. So in general we can just write what? R is the resultant and that will be equals to A plus of minus B. Okay. Let's suppose one vector is like this. This is our vector P and other vector is like this. This is our vector Q and we have to perform an operation P minus Q. What? P minus Q. So how we can write this P minus Q vector? We can just write in this format like vector P plus of minus Q vector. Okay. So if the vector Q is representing like this, means its head is towards the upward direction. So what will the direction of minus Q vector? That will be like this. Means the direction of minus Q will be in opposite direction of this particular Q. So we have to just take this vector and need to add here with the vector P. Okay, so from normal addition we better know at the point of contact one head and one tail should be added. So let's suppose head of this vector P is this and the tail of this, and this is our head point and this is our tail point. So now we have to just attach this minus Q to this particular point. So this tail and this head should be added. So I am just placing this vector Q here. So like that we can just add it. At this particular point of contact, head and tail will be added and this is our minus Q vector. Okay. And for resultant will be the closing side of these two sides. So I am just drawing a closing side, and for finding the direction of resultant, what is the procedure? Then we have to join the head of the resultant towards the head of one vector and the tail of the resultant towards the tail of another vector. So what you are getting here, this is the head point of this minus Q vector and this is the tail point of this vector P. So where will the direction of resultant? Towards the head. Towards the head means at this particular point head of the resultant and head of one vector will be added, and at this particular point tail of the resultant and tail of the resultant will be added. Now the resultant R we can write P minus Q, or we can just write in this form like R is equals to P plus of minus Q. So this is the graphical method of addition of the vector, which is just nothing, just like addition we are just performing, but we are changing a direction of one vector. We are just changing a direction of one vector. Okay, why minus sign is coming, then also I can just explain you. Let's suppose the displacement of particular vector is 2 unit along the positive x direction. So if the positive x direction is there, so what we can use? We can use the unit vector 2i cap. Okay, so this represents the positive x direction. Same, let's suppose 2 magnitude represents the negative x direction. So for negative x direction we can use what? Minus I cap. Now what you are getting, this 2i minus I cap and in between 2i cap. There is just change in direction. So due to change in direction, the angle 180 will be always introduced, and due to this particular 180 degree angle, minus sign is coming. Let's suppose this vector is what? It is A is equals to 2i cap we can write, and here it will be what? It is just minus 2i cap. So 2i cap represents the vector A, so we can just write what? let's suppose this is A dash vector. So A dash vector will be equals to minus of A cap. So whenever the direction is changing, then always we can just express vector like this. I hope this is somewhat helpful for you. So stay tuned to our channel. Thank you.